Hi, this is your 5th video for production of materials, and in this video we'll be looking at ethanol and how we can turn it into ethylene and back again. So let's begin by looking at ethanol and how we can dehydrate that into ethylene. So as we can see from this reaction, it is a dehydration reaction, so that means we'll be removing water from our ethanol. So as you can see with our OH functional group here, it is this that we'll be removing, and as you can see we've got water on the other side. Now there are some key things in order to make this reaction possible, because it doesn't happen on its own. So you won't get ethanol, put it into a container and it miraculously dehydrate into ethylene. You do need to have a few things in place. The first thing is we need extremely high temperatures, and the temperature we're looking at is about 300 degrees plus. So what will happen is ethanol is put into a chamber, and ethanol is a liquid. So it's put into a chamber and it is pumped full of steam. So we're using water at really high temperatures, and that's going to heat our ethanol up and heat it into a gas. So our ethanol at this stage, for this process to work, needs to be in a gaseous state. And then we add the catalyst of concentrated sulfuric acid. So this catalyst is going to help in producing the hydrogen ions that are going to help this break off. So once we've got our high temperature, once we've got our catalyst, we'll produce ethylene gas and water, as in still in its gaseous state, so as steam. So that's it. That's how we do it. So when we go the other way and we go from ethylene to ethanol, it's the same conditions. We still need high pressure, we still need the 300 degrees Celsius, so we still need the high temperature to sort of activate this reaction. The catalyst in this case still using our sulfuric acid, but it's going to be dilute. Okay, so in our ethanol to ethylene, we're using concentrated. And in our ethylene to ethanol, we'll use dilute. But still, same catalyst, same high temperature. And as you know already, ethylene is a gas. We'll be adding water again as steam. And our production of ethanol will again be in its gaseous state. So what will happen is once we remove this temperature, once we start to lower our temperature, the ethanol will change states back into its liquid, and then we extract that and we use it. So just to summarize, the process is quite the same for both. In terms of ethanol to ethylene, same catalyst, except it's concentrated high sulfuric acid. We need the high temperature of 300 degrees, and a water molecule is going to come off our ethanol. And then we'll have our product of ethylene. So when we go backwards and we have our ethylene, we need to ensure that we also have the reactant of water present. Again, we're using dilute sulfuric acid, same high temperature of 300 degrees, and that will create ethanol in its gaseous state. So take notes, and I'll see you in class.